Some of the very common side effects found in cocaine users like short-term alertness and energy, talkativeness, panic attacks, memory defects, cognitive impairments, reduced attention span, and changes in mood and emotions have been found today in a wider population, despite they have never even seen cocaine. But why is that happening? Because who needs cocaine when you have sugar? Can you believe sugar activates the same reward pathways in our brain as cocaine and cause similar side effects? Today we are going to talk about this. But let's first understand why reward system was developed, how it works, how drugs like cocaine activate it, how sugar activates it, and what does it mean for you. I'm Dr. Zulkifil and I'm a neuroscientist with a PhD. We talk about everything related to brain. So if you are new to this channel, please consider like and subscribe because it will help me reach more audience. But most importantly, I need your attention for the next coming few minutes because this is very important. So let's first begin with why the reward system in our brain was developed. Simply, evolution, that cunning architect, needed a way to make us want to chase gazelles through thorny bushes, crave honey despite lurking predators, expand our families, and care about tribal bonds for our better survival. So it crafted a brilliant neurological compass, the reward system, which made these things so pleasurable that it turned survival into a game we couldn't stop playing. It works by releasing feel-good chemicals like dopamine when we do things which are important for survival, such as eating, drinking, forming social connections, reproducing. This positive feeling encourages us to repeat those actions. When early humans discovered fire-cooked meat, their brains lit up with dopamine fireworks, whispering, "Remember this." The same dopamine spark flared when they shared food with their kin, turning cooperation into a biological addiction. Then the danger added risk-reward aspect when they encountered honey full of bees and potentially being stung. The neural pathways in the reward system became the maps for our survival, written in the dopamine ink. Today we still dance to this ancient rhythm, whether we are swiping dating apps, trying that new restaurant, or climbing corporate ladders. How reward system works. Reward system is a bit complex, but here we will discuss in a very simplistic way the major component of the reward system, the mesolimbic pathway. So the reward system has three main components: ventral tegmental area, nucleus accumbens, and prefrontal cortex. Neurons from the ventral tegmental area reach nucleus accumbens and prefrontal cortex. Nucleus accumbens is connected with two other areas: hippocampus, the memory center, and amygdala, the emotional center. Ventral tegmental area can be activated by both primary rewards like food or secondary rewards like money in response to sensory stimuli like, for example, aroma of the food, or anticipation of the reward like thinking about food. The neurons of the ventral tegmental area release dopamine in the nucleus accumbens. Dopamine is a primary reward-related signal, and around 70% of the reward-related neurons release it. There is 30 to 100% increase in the dopamine levels in the nucleus accumbens than the normal levels. Nucleus accumbens translates the dopamine signal into motivation, pleasure, and satisfaction. Nucleus accumbens also compares actual versus anticipated reward. So if a reward was greater than anticipated, dopamine signaling increases. If the reward was less than anticipated, dopamine signaling decreases. Now nucleus accumbens communicates with hippocampus, which is a memory center, to strengthen reward-related memories, and amygdala, which is an emotional center, to create an emotional connection. So the activity can be repeated again and again. This happens by strengthening the synapses between the neurons of these regions. The neurons of the ventral tegmental area also reach the prefrontal cortex, which is involved in complex cognitive behaviors like planning, goal setting, decision making, and impulse control. It also evaluates risks versus reinforces rewards. It plans goal-directed behaviors like this activity, like for example eating food, was so pleasurable and how it can be repeated again. So let's summarize. If the reward or the activity was successful, it will lead to more dopamine in the nucleus accumbens, which will make it more pleasurable, more satisfying, more motivating. The memories and emotions related to this activity will be stored in hippocampus and amygdala, and prefrontal cortex will help how to achieve or repeat this activity again. Now let's discuss how drugs of addiction, particularly cocaine, hacks the reward system. Cocaine hacks the neural pathways that were evolved to reinforce behaviors essential for survival. When cocaine enters the brain, it primarily targets mesolimbic dopamine system, which as we discussed is a key component of the reward system. So here is how it works. Normally, when the neurons release dopamine into the synapses, this dopamine in a normal condition is taken up back again by the neurons after a while, so this dopamine can be metabolized or can be reused again. What cocaine does, it blocks those dopamine transporters and therefore prevents the reuptake of dopamine from the synapses. Now this leads to a rapid buildup of dopamine far exceeding levels associated with natural rewards. This flood of dopamine creates intense euphoria and heightened alertness. Over time, what happens? The brain becomes hypersensitive to cocaine and cocaine-related products because they lead to more dopamine in the synapses. Now, since cocaine leads to the more dopamine in the brain, particularly in the nucleus accumbens, natural rewards become less pleasurable because they do not increase the levels of dopamine like the cocaine does. And the memories associated with this pleasure and emotions are so strong that the brain wants to repeat this action again and again. Now, the chronic use of cocaine will result in physical alterations in the areas related to reward circuitry. It will cause altered decision-making, planning, impulse control, and cognition by causing physical alterations in the prefrontal cortex. It will affect the memory by affecting hippocampus and emotions and moods by causing changes in the amygdala. The brain's stress system becomes more reactive, leading to negative moods when not using cocaine. Now let's discuss how sugar affects the brain reward system similar to cocaine. Recent research in the last 2-3 years has made things very clear why the current population is facing similar problems like drug addiction while they are not using any drugs. So first, how sugar affects the dopamine signaling. Research shows that the sugar causes rapid increase in the dopamine levels. Short-time energetic, increasing alertness for the short time. So now since there is more release of dopamine in the reward circuitry as a result of sugar consumption, therefore it potentially alters the plasticity between the different brain regions involved in reward, therefore leading to the repeated actions, more cravings and overconsumption most likely, and also making difficult to reducing the intake. Second, sugar activates the similar brain regions like cocaine. A study published 1 year ago in a very reputed journal. The researchers were shocked to find that a single exposure to sugar resulted in widespread neuronal activity throughout the brain region. What was more surprising, that it activated the more regions of the brain than cocaine. Though with repeated exposure, cocaine also started activating the more brain regions. So the study found that both sugar and cocaine strongly activated the nucleus accumbens and induced the formation of silent synapses in this brain region. Now, what are silent synapses? These are the immature neuronal connections and are thought to be responsible for the seeking behaviors associated with both natural and drug rewards. So what will happen that with the intake of sugar, you will have this seeking behavior. Your brain would want to repeat it again and again. That is the reason many people can't stop taking soft drinks like Coca-Cola, Pepsi, energy drinks. And if you look at the sugar consumption graph in the countries, it is only going up every year. I have discussed the effects of sugars on the brain in complete detail in another video which I will be uploading soon. And I hope this information helps you in deciding what what to do about sugar intake. But one thing is always recommended, that always reduce the intake of sugar gradually. So in the end of this video, I leave you with this question: are we drugging ourselves to death? Thank you so much. See you soon.